Hello everyone. In this lecture, I would like to discuss about the design of non-inverting amplifier. Before going to discuss what is meant by amplifier. Amplifier is an electronic circuit. It is going to amplify the magnitude of the signal. The real-time example of this amplifier is our microphone. Our microphone is receiving our voice signal. It to be converted into the electrical signal. This electrical signal is applied to the amplifier circuit. The amplifier circuit is going to amplify the magnitude of the input signal. This is called as the amplifier. What is non-inverting amplifier? The non-inverting amplifier is one in which the output is in phase with respect to the input. What is the meaning? Here there is no phase shift, there is a 0-degree phase shift, only changing the magnitude of the input signal. That means the amplitude of the input signal we are going to rise depends upon our design of our circuit. Here how we are going to design the circuit. In an inverting amplifier, we are apply the input in this inverting terminal. Here we are going to apply the input in this non-inverting terminal of the operational amplifier. There is a two terminal, one is inverting terminal, another one is non-inverting terminal. We are going to apply the input into the non-inverting terminal of the operational amplifier. Next, here the resistance R1. This R1 resistor to be connected in this inverting terminal of the amplifier. The another one terminal is connected to the grounder. This is the feedback resistor. This RF and R1, with respect to this RF and R1, we are going to decide what is the gain of the amplifier. We are going to discuss now how we are going to design the circuit, how we are going to set the circuit. Here there is the two nodes, that is a virtual node. Already I said VA and VB. This is the virtual node. What is our here VA? VA is equal to V1, that is the input voltage. Okay, right? That's why VB is equal to also 1 because of this is the virtual terminal. Then we are going to find the R1 resistor value. How we are going to find? We are going to apply the Ohm's law. Here I is equal to, here this this terminal to be connected as a ground. That's why this value becomes 0 minus of VB. What is VB? VB is become V1 here. This is taken as a V input voltage. V input voltage divided by R1. This is the current across the R1 resistor. That's why I is equal to minus V in divided by R1. Next, current across the RF resistor. Here VB. VB is equal to V in. That's why V in minus of V out. This node, the voltage become V out divided by minus RF. This is the current across the RF resistor. Okay. Now we are going to compare these two equations. Okay, we are going to equate these two equations. Here minus V in divided by R1 equal to V in divided by RF minus V out divided by RF. Just splitting this equation. Next, we are going to change V out come to here. This is the positive. Here minus V in divided by R1 come to this right side. This is plus V in divided by R1. In this equation, I am going to take V in is a common outside. Now the equation become 1 divided by RF plus 1 divided by R1. Now we are going to find the gain of the amplifier. The gain of the amplifier is equal to V out divided by V in. That's why we are just cross multiplied this equation. Here V out divided by V in. This RF come to this side. Now the equation becomes RF divided by RF plus RF divided by R1. Here this RF cancel. That's why the equation becomes 1 plus RF divided by R1. This is the gain of the non-inverting amplifier. By using this RF value and R1 value, we are setting the gain of the amplifier. In practical cases, we are going to put the RF resistor as a variable resistor. We are going to change. Now, I am going to demonstrate this circuit into the every circuit simulation software. Design of non-inverting amplifier with the gain of 3. Here we are going to assume our R1 resistor value becomes 1 kilo ohm. What is the RF value we are going to find? How we are going to find? Gain is equal to 1 plus RF divided by R1. Here we are going to substitute the gain is equal to 3 equal to 1 plus RF divided by 1 kilo ohm. Here now our value become 2 equal to minus RF divided by 2 kilo ohm. That's why RF is equal to 2 kilo ohm. We are going to our value becomes 1 kilo ohm and the RF value becomes 2 kilo ohm. The gain of the amplifier becomes 3. Okay. Now I am going to demonstrate. Here we are going to design the amplifier by using the every circuit simulator, just demonstrate our output is right or wrong. Here the R1 resistor value become 1 kilo ohm, the RF value become 2 kilo ohm. What is the gain of the non-inverting amplifier? Here the input is given into the non-inverting terminal of the operational amplifier. Here 1 kilo ohm, there is 2 kilo ohm, the gain become 3. We are going to apply the input becomes 1 volt, the output become 3 volt. Okay, now I am going to demonstrate this one. Okay, here this green line is indicating the input. Our input voltage is, look at here, our input voltage is 1 volt, sorry, our input voltage is 1 volt. What is our output voltage? The output voltage is 3 volt. Here clearly says this is the 3 volt. Now I am going to change the resistor value. Here the resistor value become 3 kilo ohm. RF resistor value become 3 kilo ohm. What is your output? What is our gain? The gain becomes 4. 1 plus RF divided by R1. R1 value become 1 kilo ohm. The RF value become 3 kilo ohm. 3 divided by 1, this is 3 plus 1, this is 4. That's why our input voltage become 1 volt. The output voltage become 4 volt. Here we are going to amplify the amplitude of our input signal. Here the phase shift become 0. Okay, this is our non-inverting amplifier design.